right, well, hope everybody did a good job with the ratios and stuff. So in this case, what we want to do is move on to percents. So percents are important because they come up every day. Pretty much can't do something with throughout the day where a percent isn't involved. So whether you're buying something, you're paying sales tax on it, or if you got a discount on it, you may have gotten 20% off. Um, like homeworks and stuff like that, like your percent, like a 90% is an A and 80% is a B, so things like that. So there's interest rates or the percentages all over the place. So the word percent itself actually means per hundred. So, or in formal terms, if R is a non-negative real number, then R percent written R percentage sign is the ratio R over 100. So for example, 50% we could write as 50 and then basically turn the percent into over 100. And then if we simplify this, we can get 5 over 10, which is 1/2. Or if you wanted to go even further, you could turn this into a decimal. And we see that 50% is the same thing as 1/2 or zero point 0.5 in this case, which we'll actually work on in a little bit. All right. So before we can actually do anything with percents, we need to be able to like move back and forth between decimals to percents and stuff like that. So convert the following decimal to a percent. So what we want to do, since this thing is the same thing as per 100, what you're going to do is take this 42 and actually write it as over 100. And then what we do is then we kind of change out the 100 back into a percent. So in this case, this would be 42% because anything over 100 becomes the percent sign. Or another way that you can think of it is when we're going from a decimal to a percent, what we're actually doing is moving the decimal 2 places to the right. And adding the percent sign. So 0.42, if I move this 2 places, is going to put the new decimal point after the 2. And so since there's no other number, I don't actually have to put the decimal point. But then what we do is we add the percent sign to it. So 0.42 is the same thing as 42%. All right, so you guys work on practice 1, which is doing the same thing we just did above. So either do it like divide it by 100 or changing it to just moving it to the right. And so when you're done, come on back and then we'll talk about going the opposite way, converting a percent to a decimal. All right. So in this case, what we want to do is convert the following percent to a decimal. So in this case, we just want to do the opposite operation. So in this case, we're going to move the decimal 2 places to the left and then drop the percent sign. So in this case, if we've got 37.2%, 2 places to the left puts the decimal in front of the 3. So we end up with 0.372, and again, drop the percent sign at this point. All right, so here's practice 2 and 3. So this is for you guys to work on. So let me know if you have any questions or anything like that. And then when you're done, come on back. Oh, in practice 4 also, sorry. And then come on back and then we'll talk about word problems involving percents. All right, so hopefully everybody did a good job converting things into percents. So in this case, what we want to talk about are percent problems. So the nice thing is, like when you're talking about a percent, you're really looking at a proportion of the percent to some fraction. And so if you notice, there's basically 3 variables that can occur. So that gives us 3 types of equations that we're actually going to be able to solve. So the P is obviously the percent And the A and the B are actually kind of known as what's the is and the of the problem. And we'll see when we get into them what I mean. So what happens is, there's case one where the is and of are known. So in this case, we'd know the A and the B, and then we need to solve this for P. And so we already know how to solve it. It's the same way we just cross multiply like we did before. So case two is the A and the P, the is and the P are known, and we need to solve for B. And then finally, the of and the percent are known, and we need to solve for A. So again, there's kind of one of each type here. So let's look at these and kind of break them all down. So solve the following percent problems. So what percent of 300 is 126? So again, remember we're looking for P over 100 equals is over of. So the what is always going to go along with the variable. So in this case, what percent is telling us that the P is unknown. Our is going to be the word that goes with the is, which in this case is the 126. The of is the number that goes with of. So for this problem, to set it up, it would look like P over 100 equals 126 over 300 in this case. And now from here, we're going to solve it just like we did in the last section. So really the only difference is we have to kind of set this up as word out of, undo the word problem first and then go from there. So let's cross multiply this guy. So we get 300p equals 12600. And then to solve, we just want to divide both sides by 300. And so if we throw this into our, I guess we don't have to throw it in our calculator. Well, we could, but in this case, like the nice thing is, since these both end in zeros, we can just cancel the zeros out right away to make it a little bit smaller. And then 3 goes into 126. So 4 times. And then 2 times. So it looks like, in this case, P is going to equal 42. But since it's a percent, we want to make sure we add on the percentage to it. So notice, because of the way this is set up, since it's P over 100, like we don't have to like convert this. We don't have to move the decimal 2 places or anything like that. The only thing we have to do is just go ahead and attach the percent to the answer. So kind of keep that in mind. All right, so let's look at number or letter B here. So 15 is 30% of what number? So when the percent's there, it's pretty obvious which one's the percent because it's always going to have the percent sign with it. So the unknown in this case is going to be the of what number. So that's going to be our bottom number. So this is going to be our unknown. And then 15 is going to be our top number. So in this case, 30% of what number is going to be 30 over 100. And so again, we don't have to convert this into a percent because we're writing it as a fraction. Is, and then our x is our unknown in this case. So again, same setup. Go ahead and cross multiply these guys. So 30x equals 1500. Divide both sides by 30. So again, we can cancel off one of the zeros to make life a little bit easier. And then 30 goes into 150 50 times. So in this case, x equals 50. So, all right, does that make sense to everybody? All right, perfect. So what is 45% of 20? So in this case, the what is, so the is going to be the unknown. So again, kind of writing our formula down. So the is going to be our unknown. Our 45 is our P, so 45 over 100 equals x over our of, which is 200. So again, cross multiply these guys. So 100x equals, let's see, so 9,000 in this case. And then divide both sides by 100. So again, we can wipe out some of these zeros, so we end up with just 90 over 1, which is the same thing as x equals 90 in this case. All right, so that's all three types, so one of each kind. So again, main thing is just kind of go through, make sure you can identify what's going on, make sure you identify all the different parts, make sure you put them in the right spot, cross multiply, and then solve from there. So at this point, go ahead. I got a bunch of you guys for you guys to practice. So go ahead and pause the video at this point. Go through and practice yours. And then here's some story problems doing the exact same thing. So again, you can set them up exactly the same way. And then when you're done, come back and we'll talk about compound interest for a little bit. All right, so hopefully everybody did a good job with the proportion problems. So we're going to finish up here talking about compound interest. So again, interest is another thing that comes up all the time. You know, if you have a car loan, or if you have a home loan, or if you have a credit card, or even if you just have money in a savings account at the bank that earns interest, all those things earn interest, and it's based on some kind of formula. So what we're going to do is first start off using what's called the simple interest formula. And so this comes in two different forms as I've written here. So the first one, which may look familiar to you, is called, I equals PRT, where I is the interest. P represents what's called the principal, or it's either the amount that's in the bank that you've deposited, or it's the amount that you owe on a loan. R is the interest rate, which will have to turn into a decimal. And T is the time in years. So now the only problem with this formula is when you calculate it, all it does is give you the actual interest that you've earned in the account. It doesn't actually tell you how much money's in the account. So to figure out how much money's in the account, what you end up doing is taking the interest and adding it to the principal. So what I've done is I've made like a future value equation for you down here. So if you take the principal plus the interest, and then you do a little substitution and say, okay, well, the interest we know is the same thing as PRT. And then if we just factor the P out of those, we get P times 1 plus RT gives us what's called the future value. So that'll actually tell us how much money is in the account, how much plus the principal plus the interest combined. All right. So in this case, for practice 7, we want to solve this using the simple interest formula. So if you keep monies in a bank account and the bank pays you interest at a fixed rate, suppose you invest $6,000 for a year at an annual interest rate of 5%, how much is your investment worth at the end of the year in this case? So with this one, we know our P, we know how much we're depositing. We know our interest rate is going to be 0.05. So again, turn this into a decimal, don't leave it as a percent. And our T is equal to 1. So the only thing we don't know is how much money is in the account at the end of the year. So we want to know that future value. So what we're looking at is F equals P times 1 plus RT. So now we just plug in everything that we know. So P is 6,000. 1 plus 0.05 times T, which is 1. So multiplying 0.05 times 1, we get 1 plus 0.05. Adding these two guys together, we just get 1.05. And then finally throwing this in the calculator. Hold on, I'm trying to pull it up here. So 6,000 times 1.05 gives us 6,300. So after 1 year, we have $6,300 in the bank. So how much interest did we earn in this case? Well, the interest is going to be what's over and above what we originally deposited. So if we want to calculate the interest, we would just do the future value minus 6,000, which tells us that we earned $300 interest in that year, which is pretty unrealistic. But, all right. Fix that so we can see it. So, and it didn't ask for the interest in this case, but it's sometimes good to know how to do that. So now it says, suppose you leave this investment, so in this case the $6,300 in the bank, what's the value at the end of the second year? So again, assuming everything else is the same other than the P. So in this case, we've got a new P because we've earned that 300 extra dollars, but our interest rate stays exactly the same. Our time stays the same. So again, what's our future value at the end of year 2? So again, do the same thing. So 1 plus RT. So in this case, we're going to do 6,300. 1 plus 0.05 times 1. So again, same thing. I'm just going to get 1.05 on the inside. Oops, didn't look like a 0 much. So again, throw this in the calculator. So now we've got $6,615 is our future value. So that's how much money will be in the account. And so again, not that we need to know it, but our interest would be the 6,615. Now in this case, you would go back to the beginning because we're trying to figure out how much overall interest we've earned. Now, if you only wanted to figure out how much interest you earned in 1 year, then you would do minus the 6,300. So in this case, we can see that we earned $315 more in interest in year 2. So now, keep going. We want to do the same thing end of year 3. So again, now we want to use this new future value as our principal. So 6,615, but everything else stays the same. So again, set this up same way, P times 1 plus RT, F equals 6,615, 1 plus 0.05 times 1. So again, that's going to give us just 1.05 on the inside. So again, multiply this guy out. And so it looks like we get 6,945. 0.75. And so again, if we wanted to figure out how much interest we earned in that year, we would just do 6,945, oops, 0.75 minus the previous year. So in this case, we'd get, let's see, 0.75, 0, 3, 3. All right. So if you notice, each time we're earning a little bit more interest. So it's not the same. So even though we're using the same interest rate and all that stuff, because the principal increased, the amount of interest that we're earning each time increases. And so what this is actually doing is calculating what's called the compound interest. So it's compounding this every year, and it just kind of keeps going on and on and on and on for different years and stuff like that. So what we want to do is go through and actually talk about formally compound interest, because the problem with the way we're doing it is, say we wanted to figure out what the interest was that we earned in year 10. Well, the downside is there's no way to just jump to year 10. You'd have to actually calculate year 1, year 2, year 3, year 4, year 5, the whole way up to year 9. Then you could finally calculate year 10. And so that's a lot of work, and we don't necessarily want to do that. So what we want to do is find a nice, easy way. So what we end up doing is using what's called the compound interest formula. So most of the variables you've already seen so far. So in this case, F is our future value. That's going to be the amount that's in the bank after so many years. P is our principal. R is our interest rate. T is our time in years. So the only thing that's new is this N. And notice it occurs in both the denominator and the exponent. And so what N is the number of compoundings per year. And you might be asking, what in the world is a compounding? So it's actually the number of times we calculate the interest. It's how often the interest is calculated per year. And so these are sort of the common wording that they'll use, and then we'll put the number with it. So if interest is compounded annually, that means it's compounded one time a year. So in this case, we'll get n equals 1. So semi-annually means it's compounded twice a year. So in this case, n will be 2. Quarterly means it's 4 times a year. So we'll get a 4 for n. Monthly means 12 times a year. So n will be 12. Weekly would be 52 times, every week. So 52 times a year. And daily means at the end of every day, they'd calculate the interest. So it would be 365 in that case. So let's go through and look at a practice problem here so we can kind of see what's going on. So suppose your credit card charges 18% interest compounded monthly. So they're never going to give you the N. They're always going to give you some kind of a word, compounded annually, compounded semi-annually, daily. So you have to be able to decipher that to figure out what the N's going to be. So if your credit card was maxed out at its limit of 2,500 and you're unable to make any payments for 2 years, and assuming no penalties, how much debt would you owe based on compound interest alone? All right, so again, if we remember our formula, so we need to know F, we need to know P, we need to know R, we need to know N, and we need to know T. So in this case, our F is the thing we're looking for. Our P is going to be the 2,500. Our interest rate is the 18%, but as a decimal, so 0.18. Our compounding is monthly. So again, if you forget, just go up to the chart. So n equals 12. And our time was the 2 years in this case. So again, plug this into our compound interest formula. So we get F equals P, which is 2,500. 1 plus 0.18 divided by 12, all raised to the 12 times 2. All right, so on this one, I'm going to show you how to do it on your scientific calculator, or not scientific, but the TI calculator, just in case you have one, because there is a possibility you can make a mistake here, so you want to be really, really careful. And it comes down to the exponent, and that's why I put the parentheses around it. So in this case, if I go to the calculator, I've got 2,500. So basically you want to type it in exactly the way I wrote it. Same number of parentheses and everything. So 1 plus, 0.18 divided by 12 parentheses. So depending on what kind of calculator you have, so mine, since it actually moves up into the exponent, it's going to work perfectly fine, but some of you guys have calculators that use the caret, or if you're using your phone calculator, for example, it's really important to do this. You want to make sure that you put parentheses around that exponent, because if you don't, what's going to happen is just the first number is going to get raised to the exponent, and then it's just going to multiply that answer by the time, and you're going to end up with a really, 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 really big number. So make sure when you do the exponent, you always put parentheses around the exponent, or just go ahead and multiply the two numbers in the exponent together and just type in that number after you multiply it. So either way, that's what you want to do for that. So for ours, so we have the 12 times the 2 in parentheses. So it looks like we get 3,573.76. Oops, that's not it. So 3,573.76. And so in this case, that's how much we would owe total. So if you can, if you subtract this number from 2,500, you can see how much interest we were charged, which is kind of a disaster here. So 3,573.76 minus 2,500. So we can see that in just 2 years of making no payments, we end up almost getting charged almost half of what we actually owed just in interest alone. So that's why credit cards are a little scary when it comes to stuff like that. So I mean, that's a lot of interest. Now, granted, we didn't make any payments or anything either, but so that's still a lot of interest that you can get charged. All right, so what do we do the same thing, but now we want to do it for 4 years. So again, everything's exactly the same. except for our time is now going to be 4. So again, just writing the formula down, make sure we start to memorize it. So 1 plus 0.18 divided by 12, all raised to the 12 times 4. So again, if I go back to the calculator, so 2500, 1 plus 0.18 divided by 12, caret, then parentheses, because I'm in the exponent spot, 12 times 4. So in this case, 5,108, 60, or 70. And so again, if we wanted to figure out how much interest we were actually getting charged, six. So in this case, we're actually getting charged in just 4 years. So again, this is assuming we didn't make any payments or anything like that, but we're actually paying more in interest than we actually did for whatever we had purchased in this case, which is a little bit scary. So, all right. So, oh, actually, I was supposed to let you guys do that one. Oh, sorry. Well, ignore that I did it. So, you guys were supposed to do that one on your own. Sorry about that. So the last one is practice 9. So go through. This is just having you go through and practice converting things from percent to fractions and stuff like that. So if you guys have any questions or anything like that, I'll be around the computer all day. So good luck and happy finishing up the last unit.